Good afternoon to everybody that has joined us today. My name is Letu Shabalala from GoDigitalSA Foundation. Today, it's a special day. So we have Dave Similink joining us today to share his insights on MakeCode MicroBit, the BBC MicroBit. If you have never seen it before, today is your chance to see it and see how it works. So Dave is the Chief Technology Officer and co-founder of GoDigitalSA Foundation. He started off his career in electronic engineering, which he taught for 4 years before becoming a professional software developer, which he has been for nearly 40 years. Wow. Working in the US, South Africa, and other countries in Africa. These days, Dave enjoys creating electronic and software projects and enjoys teaching these skills to others. So yeah, we have something in common. So Dave will be presenting today about BBC MicroBit and the Microsoft MakeCode. Welcome, Dave Semmelink, aka Uncle Dave.
Okay, all right, thanks, Letu. Okay, firstly, can everyone hear me? I hope you can, and I hope Letu will let me know if you can't. Okay, so today I'm talking about Microsoft MakeCode and the BBC MicroBit. If you caught Letu's talk on Tuesday, he talked about writing software for personal computers and smartphones. And so now we're going to be talking about creating programs for a completely different type of computer, one we normally call a microcontroller. Okay, so what is the BBC MicroBit? Okay, it's a small, relatively inexpensive computer. It can run from a battery pack, as you can see here, and it was designed so that you could create your own fun projects, and you can learn a lot about computer science from it. So we'll take a close look at it. This is it from the front. It's got two input buttons, A and B. It's got an input light level detector that detects light. It's got a display made up of 25 LEDs. And it's got along the bottom general purpose input output pins for connecting to other devices, as we'll see just now. This is the MicroBit from the back. It's got for inputs a compass, an accelerometer. You don't see here an inclinometer, which tells you pitch, roll, and yaw, which we might talk about in a minute. And along the top, you'll see there's a Bluetooth antenna, there's a micro USB connector, and there's also a reset button and a battery pack connector. And along the bottom are the same GPIO pins. Okay, the 5 big connections there make it easy for you to connect the MicroBit to various devices. There's holes in the pins so that you can use banana connectors, or you can also use crocodile clips, and you connect the pins 0, 1, and 2 to devices like speakers or earphones or other modules. And it's also got 3 volts and ground so that you can connect power to those devices. Let's just take a look at some of these modules that you can get. Here's a sensor board, and you can see it's also got big holes around the edges so that you can connect it to the MicroBit, and it gives you a microphone, a thermometer, and a light meter. Here's a relay board. It lets you connect to things like sirens, flashing lights, motors, and so on, so you can turn them on and off. One thing you have to keep in mind is that the pins on the MicroBit can't drive a lot of power, so the relay board allows you to drive more powerful devices. There's a servo board that lets you connect to servo motors. Servo motors are just motors that you can control to turn things. And here somebody's made a robot face with eyebrows and eyes that can move. Okay, there are a total of 25 pins, so you can connect a lot of things to the MicroBit. And to connect to those 25 pins, you use a connector, and then you get modules that have a connector on them. This module lets you connect 8 servo motors and 8 other input-output devices, gives you a battery, and so on. Here you've got a robot. You can see that the MicroBit is plugged into the robot. So the MicroBit controls the robot. A gamepad module lets you turn the MicroBit into a gamepad with a joystick over here and buttons. Here's a display you can add to the MicroBit. A piano keyboard if you want to make music, and so on. This is just a plain connector that lets you create your own devices using the MicroBit. Okay, so that's the basics of the MicroBit. So what is Microsoft MakeCode? So MakeCode is a development environment for creating programs to run on a MicroBit. Creating programs, or sometimes called coding, requires you to learn the basics of computer science. For example, we've got a 14-day Introduction to Computer Science course that consists of 12 units, 2 to 4 hours each, covering the most important elements of coding. For this web talk, I've condensed the first half of the course down to 1 hour. So we're going to do the first half of the course. We're going to do these units: making with MakeCode, processing in algorithms, variables, conditionals, iteration and looping, and then a quick revision. We can do another web talk on the second half of the course at another time. So let's get started with Unit 1. Okay, Unit 1 is making with the MicroBit. Okay, to start Microsoft MakeCode, you open a browser. It can be Chrome or Edge. You enter the URL makecode.microbit.org and press enter. That brings you to the home page of MakeCode. You'll see that it says My Projects. Below that, it's got New Project. You press that button if you want to start a new project. After you've created a project and saved it, it will show up in a list next to New Project. So we're going to click New Project and get to the main screen of MakeCode. And along the top, you'll see Go Back to Home Page, Share to share your project, Blocks and JavaScript. That's so that you can program in either blocks or JavaScript. We're going to be using blocks, but JavaScript is another very popular programming language. There's a simulator that shows you your program, or what your program will look like when running on a MicroBit. And it's got a toolbar for controlling the simulator. There's a block toolbox that's got categories of blocks. We'll call these drawers. So you've got a basic drawer, input drawer, music. When you click on those, it opens up a list of blocks. There's a programming workspace where you will build your program. You build your program by dragging blocks from the block toolbox onto the workspace. You can download your program to an actual MicroBit. You connect your MicroBit to your computer using a USB cable, and when you click the button, it loads your program onto an actual MicroBit. When you've written a program, you should give it a name and save it. So you type the name in here. When you click on this button, then it saves it to your computer. There's an undo and redo button so that if you've made a mistake, you can undo it. And there's zoom, so you can zoom in and zoom out on pieces of the workspace. Okay, so we'll create a program in MakeCode. Okay, so I've gone to Chrome. I'm going to click on New Project. Okay, and you can see that when you start a new project, it always has an on start and a forever block on the workspace. Okay, so we're going to create a program. The first program we ever create is called Hello World. You want it to display Hello World. We go down the list of blocks. Our first drawer is basic, and you can see the blocks in there: show number, show LEDs, show icon, show string, and so on. Let's take the show string. We drag it out here, place it in forever. That means that show string hello is going to show forever. It's going to run forever, and you can see it running on the MicroBit. Okay, one of the concepts you have to learn about computer programming is that you should save early and save often. So let's call this program Hello World. We click on save. And you can see that it has saved it to a file on the computer. Okay, let's just modify the program. it was hello. Let's make it hello world. So you type in there world. And now you'll see on the simulator that it displays hello world. Okay, so that's our first program. Let's download it to an actual microbit and see how that works. Okay, I've got on my table here a microbit, and let me just quickly review. This is a microbit. You see it's got the 5 connectors there. This is a banana plug, so you can just plug a banana plug into the hole. And this is a crocodile clip. You can just clip a crocodile clip like that. So that's how we do our connections. I've just connected a servo motor there. I've got a battery pack. I'm going to turn it on. I've loaded a program here just to demonstrate all of this. And this will let it detect light. And you'll see that the display changes and the servo motor changes what it's doing depending on the amount of light. The white clip is connected to an earphone like this. And hopefully you can hear. Does it make sound? And I can change the sound by changing the amount of light. Okay, so that's just so that you can see how a microbit looks and how it works. Take that away. We now want to take our program and load it onto this microbit. So I've got a USB cable connected to the computer. I'm going to plug the USB cable into the microbit. Being careful to connect it the right way around. And okay, you will see that that light lights up. That shows you that it's connected. And now, let's download the program. If you click on download, you should see this light flashing. Okay, if it does this, it means it didn't work. I need to synchronize it. You sometimes have to do this. You go into the settings, go to pair device, click on pair device. There's the microbit, click on connect. You normally just have to do that once, but you might have to do it once in a while. Now it's paired. So now when I click on download, you see the light flashing. The program is now loaded. And if we look at the other side, it should say, hello world. Okay. Okay, we finished with our program. I think we saved it, but for safety's sake, just save it again. We click on home, and now we see that hello world is saved. If we want to go back to it, we can just click there and we're back to our program. Okay, so that was unit 1. Unit 2, algorithms. Okay, before we talk about algorithms, let's talk about computers. There are 4 main parts to a computer. There's a processor. It's what the computer uses to process and transform information. It's also known as the CPU, or central processing unit. There's memory, how the computer remembers things. There are 2 types of memory: RAM, or random access memory. This is the computer's short-term memory. It loses whatever's in RAM when it loses power. And there's storage, hard drive or flash drive, the computer's long-term memory. Whatever you put on the hard drive or the flash drive, it stays on the computer even when the power is turned off. This inputs how a computer takes in information from the world, and outputs how a computer displays or communicates information. So what does a computer do? Computer executes a set of instructions given to it by a programmer. The instructions will tell it to do any combination of the following: accept input from 1 or more input devices and store it in RAM, process information stored in RAM in some way, output the results of the processing to 1 or more output devices, and store the results of the processing in its storage. Okay, so the microbit is a computer. It has got a CPU, it's got RAM, and it's got flash storage. It's got input devices. It's got output devices. So it is a computer, just like a desktop computer is a computer and a smartphone is a computer. Okay, so what is an algorithm? An algorithm is a set of rules to be followed in calculations or other problem-solving operations. Pseudocode is a set of instructions we will give the computer, written in a form that is easily readable by people. And a program is a set of instructions that a computer is able to execute. The instructions are given in a computer language. There are many computer languages. We will use the block language of MakeCode. MakeCode lets us switch between blocks in JavaScript, which is another very popular computer language. Okay, so we're going to code with event handlers. So we're going to write a program, and this is our algorithm. We want to start with a blank screen. Whenever the user presses button A, we want it to display a happy face, and whenever the user presses button B, we want it to display a sad face. Okay, we can see what it should look like. So when you click button A, you should get a happy face. When you click button B, you should get a sad face. When you start, it should be blank. Okay, so in MakeCode, we're going to create a new project. We'll name it Happy Sad Face. We're going to add comments, and I'll show you what comments are just now. So let's get going. Okay, so we click on New Project. Our algorithm said that on start, we want the display to be blank. The on start event happens whenever you turn the MicroBit on, whenever you apply power to it. Okay, we'll look through our drawers here and we'll see here, we've got clear screen. If I put clear screen on start, that means when you turn on the MicroBit, it will clear the screen. And that's all it's going to do. When button A is pressed, we want it to display a happy face. So pressing a button is an input. If we look in the input drawer, we see on button A pressed. So I'm going to put this here. We want it to display a happy face. If we look through here, show LEDs, we could use that because we can draw a happy face. Okay, but I'm not going to do that. So I'm going to throw this away. And instead, I'm going to use this, show icon. Show icon lets you choose from some common images. And here we've got a happy face. Okay, so when somebody presses button A, it's going to show this happy face. And we can test this now. And you see that it is working. Okay, you remember I said save early, save often. Let's save this. We said this is going to be happy sad face. So that's the name I give it. And I click on save. Okay, now on button B pressed, we want it to show the sad face. I could do the same thing. I can take on button B. Now you see that when I pulled it out, it's grayed out because it says on button A. You can't have two on button A's, but I can change the A to a B, and now it's going to work. Okay, and I can go back here, show icons, change this to a sad face. Okay, we've done some programming, so we should save. Okay, when we press button B, we get a sad face. When we press button A, we get a happy face. Okay, and I said I wanted to show comments. A comment is information that tells you what the program is doing, and or it can tell somebody else who's looking at the program what it's doing, just in case it's not obvious. So we want to add a comment here. If I right click, then I get an option here, add comment. So I can add a comment that says when button A is pressed, show a happy face. Okay, and this can be in any language. You can say anything there. The computer doesn't execute this. This is just so that you or somebody reading this program will know what was meant by this code. And you can do the same for this. add a comment here. Okay, so when button B is pressed, show a sad face. Okay, we finished programming it. We can save it. And if we want, we can download it to our MicroBit, but I won't do that to save time. Okay, we're done. We click on Home, and now you'll see the happy sad faces here. The hello world is still there. Okay, so now let's talk about variables. Okay, a variable is information with values that may change during a program. For example, team equals home or score equals 25. There are different types of variables depending on the kind of information they hold. I'll show you that just now. And in MakeCode, the type of variable is assigned the first time you use a variable. From then on, you can only change the variable value to another value of the same type. Okay, and then constants, a constant is like a variable, but with values that don't change. So if you have something called pi and you set it equal to 3.14, we can say that's a constant because pi is always equal to 3.14. Okay, the types of variables in MakeCode, you get numeric variables, which holds numbers. A string variable holds a string of alphanumeric characters, punctuation, symbols, and so on. Okay, so we had team is equal to a number or name is equal to a person's name. So that's a string. Boolean, this has only two possible values, true or false. An array is a variable that holds a list of multiple values. And a sprite is a special variable that holds two values for the row and column to represent the location of a dot on the MicroBit screen. Okay, not all programming languages will have sprites. Okay, so let's try to make a game Scorekeeper. We're going to code a game Scorekeeper with variables. We'll create variables A, B, and T for scores and ties. So A is going to be the score for team A, B will be the score for team B, and T will be the score when they both tie. So you set the variables to 0 on start. You increase the score A when button A is pressed, increase score B when B is pressed, and you increase T when A and B are both pressed at the same time. You have to show these values or showing user feedback, and then we want to show the totals by adding the scores. Okay, so we'll go back to the browser and try this. Okay, so we'll see in our toolbox, there's a drawer here called variables. We can make variables. You should always make the variables easy to read and understand. So we can say A score for the score for team A. We make a variable B score for the score for team B. And T score for the ties. Okay, then we want to set them to 0 when we start. We've got to set to 0. So on start, we set A score to 0. Okay, and let me just show you a quick way of doing this. I'm going to set B and T to 0, but instead of dragging them out from the toolbox, I'm going to duplicate this and change that to B score. And then I'm going to duplicate this and change that to T score. So on start, we've set all the scores to 0. Okay, so next, when button A is pressed, we want to increase the value of A by 1. So we're going to say it's an input on button A pressed. We want to change A score by 1. So change A score by 1 means that it's going to increase A score by 1. So each time you press button A, it will increase by 1. We can test this, but we won't see anything because we don't have any output. Okay, so we need an output. I'm going to go back here. We've got show string. And let's say I make string to A score. Okay, because the display is short, let's just call this A. And then we're going to show a number. And the number is the variable, the value of A score. We want this to display for a while, so we'll leave a little pause after that. We've got a pause blocks. It pauses in milliseconds. You see that it's pausing for 100 milliseconds. I want it to pause for 1 second. And so now the pause is for 1,000 milliseconds. And finally, we want it to clear the screen after it's displayed the score. So now when I press A, it will display A in 1, pauses for 1 second, and then it clears the screen. Okay, now we want to do all the same for B. Instead of doing everything, again, I can just say duplicate, and now it duplicates everything within this block. It's gray because you can't have 2 on button A's. I change this to a B. I change A score to B score. I change the string that it's going to display to a B. Okay, so now when I click B, it shows B 0. Oops. B 0. Okay, because I am displaying A score. I have to change that to B score. So B1, B2, B3. Okay, button A still works. So A1, A2. Okay, and finally we want something to show the ties. And again, I'm going to duplicate all of this. And I'm going to change it to A plus B. So when we go on button A plus B, and that means that the user will hold down both buttons A and B together. Then we want to change T score. Let's just get it to display a T. Oops. Okay, so when you press both buttons, it's going to change T score by 1. It'll show a T, and then it will show the number T. Okay, in the simulator, because we're using the mouse, we've only got one mouse pointer, so it's added an A plus B button. But on the actual MicroBit, you hold down A and B together to do this. So here I'm going to click this. You see T1, T2, and so on. Okay, that's our Scorekeeper. Now I said we have to save early and save often. I should have saved at the beginning, so I'll save it now. And this is a Scorekeeper. Call it Scorekeeper, and I click on Save. Okay, so that's our Scorekeeper. Oh, finally, we said we wanted to display a total. So if we click any of these buttons, A or B or A and B together, it's always changing the score. Now we want to get it to display the totals. So I need a different input. So I look through the inputs and I see we've got an OnShake. OnShake means that somebody shakes the MicroBit. So OnShake, I want it to show all the scores without changing them. I'm going to duplicate this and then take just the parts I want. So it's going to show string A, show A score, and it's going to pause and clear the screen. I'm going to throw that away. Then I'm going to duplicate this and take just these parts. So now it's going to show string B, the B score, and pause. And then I'm going to duplicate this. So it's going to show T, T score, and pause. Okay, so let's try our Scorekeeper. So when A scores, we click A. If A scores another point, we click it again. If B scores, we click B. If there's a tie, we click A and B together. Okay, and then we can shake it. Now, obviously you can't shake the computer, so it's showing you shake here. So if we click on this, it's like we're shaking the MicroBit. And you'll see it shows A is 2, B is 1, and tie is 2. Okay, so that's that program. We'll save, go back to home, and you'll see we've got Scorekeeper here now. Okay, Unit 4, we talk about conditionals. So what is a conditional? It's a rule or a condition that must be met in order for an action to be carried out. It's written as an if-then or if-then-else. You can also nest if statements so that you can have an if-then, else, if-then, else, and so on. And we'll see that just now. So we've got examples. If you clean your room, then you can go out with your friends. Or if you do your chores all week, then you get your allowance, else you are grounded. And if the time is before 6 a.m., you can sleep. Else, if the time is before 7 a.m., you must eat breakfast. Else, you go to school. Okay, we're going to do a rock, paper, scissors game. And in this game, we want a person, player A, is going to play against the MicroBit. And it will be player B. Player A does rock, scissors, paper with one hand, then shakes the MicroBit, which will display a rock, paper, or scissors at random. Player A presses button A if he wins and button B if the MicroBit wins. After 3 games, you can check the total by pressing A and B. Okay, so we're going to be using OnShake to get the MicroBit to show the hand. We're going to pick a random number to choose rock, paper, or scissors, and we're going to use an if, then, else, if, else block for the 3 choices. Okay, and we'll see that in the example. Okay, so new project. Okay, so we'll start with an OnShake. We want to set the hand to a random number, so we need to create a variable, and I'll just call it hand. Okay, and we want to set the hand to a random number. So we're taking the hand, OnShake, we're setting it to something. The something we want is a random number. Random numbers is a math function. So if we look in our list of math functions here, we see a pick random. So we're setting random to a random number, and we want it to be a random number between 1 and 3. So it's going to be 1, 2, or 3. So we want it to display a rock if it's 1, paper if it's 2, and scissors if it's 3. So now we're going to logic. We want an if else. We want to say if hand is 1, then display a rock. So we go to our variables. No, we go to our logic. Now our variables will take hand. We say if hand is equal to 1, then we want to display a rock. Okay, so I'll go here. We've got show LEDs. Let's draw a rock. Okay, that's a rock. It's not a lemon. Okay, now we want another else. So I've added an else if. I'm going to take this whole section, duplicate that. So now else if hand is equal to 2, then we want it to display paper. So I'll just duplicate that. And we'll say paper is like that. Okay, so when you shake it, it's going to set hand to a random number between 1 and 3. If hand is 1, it displays a rock. If hand is 2, it displays paper. So if hand is 3, now we don't have to check to see if hand is 3 because that's the only thing it can be. So that's going to go into our else. We can just show LEDs. So I'll duplicate this. Okay, and we need scissors here. Okay, that will be our scissors. So if hand is 1, displays a rock. If hand is 2, displays paper. If hand is 3, it displays scissors. Okay, let's try this. We'll shake it, and we get scissors. Shake it again, we get a rock. Shake it again, we get scissors. Scissors, rock, 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 scissors, paper. Okay, so that appears to work. Okay, and then just to finish this, we wanted it to keep the score. So when the user plays this, if he wins, he clicks on the A. If the MicroBit wins, clicks on the B. So we just say on button A pressed. We know we need a variable, so we'll create a variable called A, another variable called B. Okay, we're going to set A to 0 when we start, and we're going to set B to 0 when we start. Okay, so when A is pressed, we remember from the last program that we're going to change A by 1. We're going to display A, display the value of A, pause for 1 second, and then clear the screen. Okay, we duplicate that. When B is pressed, we want to change B by 1. We'll show B. We'll show the value of B. Okay, so now we've got a working game. So I'm player A, I do a scissors, then I shake it. It does paper, scissors cuts paper, so I win that round. So I do scissors again, shake it, it does scissors, we're tied. Let's say I do scissors again, I'm cheating. It does paper, scissors cuts paper. Okay, so that was our 3 rounds. And so I've won. Okay, I think we can end that one there. I'm just going to call this rock, paper, scissors. Paper, scissors. And save that. And go back home. Okay, let's open the browser and start coding. Right, okay, Unit 5's iteration. Iteration is another word for repetition. You can iterate or repeat a process or sequence of steps. In a computer program, iteration is done with the help of loops. A loop allows a computer to repeat lines of code. There's 3 basic types of loops. A repeat loop, which repeats code for a given number of times. A for loop, which repeats code for a given number of times using an index, and you can use the index within the loop. And a while loop, it repeats code while a condition is true. So when to use each type of loop, the repeat loop simply repeats code a set number of times. The for loop is useful for when you have a variable in your loop that you want to increment each time through. And the while loop is useful when you want your program to loop until a certain event happens or a different condition is met. There's one other loop that we've already worked with, that's the forever loop. Everything in the forever loop is repeated from the time the MicroBit is turned on to the time it's turned off. There can only be one forever loop in a program. Okay, some ways to use loops. Use a repeat loop to make a sprite walk a square. So we're going to use a sprite and make it move and turn. Use a for loop to make an LED light move across the screen from left to right, top to bottom. Use LED plot and unplot. and use a do-while loop to create a microbit alarm that will sound if someone shakes the microbit, and it will continue to sound until someone presses the button. OnShake will play 2 alternating tones until button A is pressed. Okay, so let's try it. Okay, so we'll do 1 project each. Okay, so for the first loop, let's just make sure I get this one right. Okay, we want a sprite to walk in a square. Okay, when button A is pressed, so we'll start by creating a sprite. And you remember in MakeCode, when you make a variable, it doesn't have any type of type. So I'm going to create a variable called sprite. And then when I set the variable sprite to a sprite, it will become a sprite. Okay, so we have to create a sprite. Sprites are found in the games drawer, and that's under advanced. So we go down to games, we've got create sprite. Okay, so we set sprite to a sprite, and we'll start it at 0 and 0. 0 is the column and 0 is the row. So it's going to create a sprite there. So onStart sprite is set here. And now we want it to walk when we click on button A. So on button A is pressed, we want to get it to move forward 4 columns and then turn 90 degrees, then move down 4 rows and then turn 90 degrees, and then move another 4, turn 90 degrees and move again. Okay, so we're going to have a loop. This is repeat 4 times. Okay, this happens to be 4 already, so that's fine. We're going to take our sprite and move it. So we'll move it by 4 blocks. And then we're going to turn it. And we'll turn by 90 degrees. Okay, so I'll just click the button, you'll see what happens. It moves. Okay, now you don't see much happening, and the reason is that because it's happening so fast. We're going to slow it down in the simulator by using the slow-mo button. So now when I click on button A, you'll see everything happening in slow motion. So it moves forward, turns 90 degrees, moves forward, turns 90 degrees, moves forward, turns 90 degrees, moves forward. Okay. Okay, so that's a simple example of the repeat loop. I'll call this repeat. Save it. Go home, we want to create a new one. And this one is going to be our for loop. And for this one, we want to plot the LEDs. So we'll turn on the LED for a few seconds, for a 1/10 of a second, and then we'll turn it off and then turn on the next one. And we'll do that through all the LEDs. So we're going to do this forever. Okay. So in our loops, we'll use for. I need variables for X and Y, so I'll go to variables. Make a variable X, make a variable Y. Okay, so we'll say when, okay, for X from 0 to 4, we want to plot an LED So we'll plot X, so X is going to be 0, then it's going to be 1, then it's going to be 2, then 3, then 4. So we'll plot it, we'll pause for a short time, and then we'll unplot it to turn off the LED. Okay, so now because this is forever, it's going to carry on doing this forever. So plots X, okay, I need to unplot X and Y. And so now you see that it's going across all the columns. Okay, now we also wanted to do the rows, and to do the rows, we're going to also have a for loop for y. So I go back to loops, for, go to our variables, and say for y, from 0 to 4, we plot x and y, and we unplot x and y. Okay, and so now we see it going from the top all the way down to the bottom. Because it's in the forever loop, then it repeats this again. Okay, so this is the for loop. I'll save that. Okay, and then the final loop is the while loop. We want a condition to be met. Okay, so when the microbit is shaken, the input is an OnShake, we want it to sound an alarm. So to sound an alarm, we're going to use a loop, a while loop. We want it to play 2 notes over and over again. Until button A is pressed. So we want it to play those 2 notes until button A is pressed, then it has to stop. So it's going to do this while button A is not pressed. So we're going to go to logic and take a not, because we want button A is not pressed. And you'll remember we've been using on button A pressed, that's an event, but now we want a condition. And we see down here we've got a condition, button A is pressed. So we're saying that while button A is not pressed, it's going to do whatever's inside here over and over. We'll play a note, so we'll use music, we'll play a tone, a middle C, and then we'll play another tone, a high C. Okay, so when we shake it, if button A is not pressed, it's going to play these 2 tones, and it will go in a loop over and over and over until button A is pressed, and then the loop ends. So I shake it. When I press button A, it stops. Okay, this is our while loop. Right. Okay, so that's the first half of the course. We've got a review. We've done making, processing and algorithms, variables, conditionals, iteration and looping. So that's the end of the web talk. This is the end of the first half of the Introduction to Computer Science with Microsoft MakeCode and the BBC MicroBit. Okay, in the second half of the course, we do coordinates, booleans, bits, bytes, and binary, radio communication, arrays, and we have a review and a final project. Okay, so that's the complete course. Okay, that's it. If there's any questions, then we can put them in the comments.
So thank you very much to everybody that joined, and thank you very much, Uncle Dave, for an enlightening presentation on how to develop programs using the MicroBit and the MakeCode, the Microsoft MakeCode. Hoping that we all learned something new today, and we will be using what we have learned to go beyond the COVID-19 lockdown. Thank you very much.